So we're recording now. Okay, so I'm picking up with this example 3 from last time. We found the y values given these x values, and now we're going to graph them. So I'll graph them in red so we can see them clearly. We have 0, 4. So x is 0, y is 4. 1, 2, 3, 4. So that point is called the y-intercept. The y-intercept. Now, does this mean it's the only y-intercept? Well, maybe, maybe not, right? So we'll look at that after this example. Then I have the point 1, 1, which is right there. Then I have the point 2, 0. So 2, 0 is 2 for x and 0 for y, so that's an x-intercept. Then we have 3, 1, so now I'm climbing back up, and then 4, 4. Okay, so we're seeing this symmetric nature here where it's acting like this on one side and like this, and it gets steeper and steeper the further we go out, right? It's going steeper and steeper. And there it is. There's the shape of y is equal to x minus 2 all squared from our table of values. Okay. So what if we wanted to find all x and y intercepts of, so let's find all x and y intercepts of y equals x minus 2 all squared. How would we do that? How would we do that? Well, we would say to find x-intercepts, to find the x-intercepts, I'm putting s in parentheses because there may only be one. To find the x-intercepts, we set y equal to 0 and we solve. Solve for what? Well, solve for what's left, which will be x. So 0 is equal to x minus 2 all squared. So I'm setting the y right there to be 0. And then I'm going to solve for x. How do I solve for x here? Well, the first thing I need to do is get rid of this square. I need to unpack this x minus 2 right here, but it's buried under a square function right there, exponent of 2. So in order to undo that, I take the square root on both sides, because I know a square root will cancel out that square right there, and that's going to give me, well, square root of 0 is just 0. And then just x minus 2. I don't need the parentheses anymore because the exponent is gone. And then, of course, x will be 2 now. X will be 2, just adding 2 to both sides. Okay, so I only ended up with 1. Why did I only end up with 1 x-intercept? By the way, what is the x-intercept? I didn't officially write it. It's 2, 0, right? 2 and the y value is 0, 2, 0. And that is reflected here in our graph. The only x-intercept is a 2, 0 right there. If the parabola was shifted down, then it would start to cross in 2 places, right? Like that last example we did on Wednesday. If you took this parabola and moved it down, then the shape of it will start to intersect in 2 places on the x-intercept. In fact, I could also shift it up, and then it would never intersect the x-intercept. So there's possibilities for these parabolas to have 1 x-intercept when it's right on that x-axis, to have 2 x-intercepts when it's shifted down, and to have 0 x-intercepts if it's shifted up. That's going to be an important point about parabolas that we should note. And in fact, I'll probably write it after we finish this problem here. So let's find all y-intercepts now. So to find the y-intercept, or intercepts, we should set x equal to 0 and solve for y. Now we know from our picture that we should get 4, right? Because that was our y-intercept earlier. It was 0, 4. So let's see what we get. So I'm saying y is equal to 0 minus 2 all squared. That's going to be y is, I don't need to, the solve for y part, I don't really need to solve for y. It's already isolated, right? So all I need to do is just kind of clean this up here. So that's going to be -2 squared, because 0 minus 2 is -2. But of course, that just gives me 4, right, for the y value. So my y-intercept is 0 for x, right, because that's what the definition of a y-intercept, 0 for x, and the y value is 4. Okay, so we found one x-intercept and one y-intercept. And a parabola will always only have one y-intercept. So since I said it verbally earlier, let me go ahead and write down those facts that that I just said about parabolas, which is that parabolas remember, parabola is the shape, right? Parabolas will always have only one y-intercept. Parabolas can have 0 x-intercepts if they have been scooted up. As a quick example of something that's been scooted up, like in equation form, something like y equals, now we saw one that was scooted down last time, and if you recall, how was it scooted down? It was like x squared minus 1, right? And that scooted it down by 1, so x squared plus 1. And what does that look like, by the way? We could graph it, but I'm just gonna kind of just tell you what it looks like just to save time. The picture of this, just a real quick sketch, is going to be a parabola, x squared. Y equals x squared is a normal parabola, but it's going to be scooted up slightly, like that, scooted up off the x-axis. That's x and that's y right there. So remember, what am I saying here? Parabolas can have 0 x-intercepts if they have been scooted up. Well, this is an example of one. It's been scooted up. What is an x-intercept? It's where it crosses the x-axis, but it's not. It's not going to cross the x-axis because it's up here, right? Now, if I flipped it upside down, then it would, but we'll get into that. That's getting into some extra details there that we don't need to discuss yet. What is the other case? Parabolas, there are 2 more cases for x-intercepts. Parabolas can have, like the one we just looked at, one x-intercept. If what? If they have not been scooted up or down. So something like y is equal to, I could just put y equals x squared, like the classic base parabola, y equals x squared, but I'll be a little bit more interesting and say like y equals x plus 1 all squared. So it's very different cases here. This, when, remember I said earlier that in example 3, when you add or subtract stuff inside directly next to the x, that scoots the x values. So this scoots it left or right. It would actually scoot it to the left if it's a plus 1. A little counterintuitive, it scoots it to the left. We're going to really talk about that later, about this whole scooting thing. But the point I want you the thing to note right now is that this thing would only have one x-intercept because it's riding right along that x-axis, right along the x-axis. So it's only going to cross the x-axis in one spot, right there, right at like the tip of the parabola, or the bottom of the parabola. And of course, the last case, parabolas can have 2 x-intercepts if they've been scooted down. So we've got the scooted up case, scooted just left or right, not scooted up or down, right, case, and then the scooted down case, which is going to be something like y equals x squared minus 1 outside, right? Not in next to the x, because if it's in next to the x, that's this way. If it's outside the x squared, that's up or down, and since it's a negative, it's down. What will that picture look like? We actually, I believe we sketched this one, and it looks just like this, like that. And we see the two x-intercepts happening there and there. Whoops, right there and there. So as another quick example, with another example with a parabola. Let's not worry about graphing this one. Let's just find the x and y intercepts of y is equal to x squared minus 4. So we should expect two x-intercepts. Based on off the facts up here, we should expect one y-intercept because parabolas will always have only one y-intercept, and this is clearly a parabola based off of what we said earlier. And we should also expect two x-intercepts because we recognize that something has been subtracted from the outside of the x squared here. That means it should be shifting down, so we should expect two x-intercepts. Oh, there's a chat. Sorry, I was really going. Okay. So let's find the x and y intercepts of this graph. Oh, I'll leave it in red here. So x-intercepts. Again, putting it in parentheses, the s in parentheses, kind of acting as if I don't know there's two. What if I didn't know there was two? Well, let's see what happens in the math here. We're going to set y equal to 0 and solve for x. 0 is equal to x squared minus 4. But how do I solve this? Well, I'll add 4 to both sides, right? Order of operations, right? So, I don't want to unpack the square yet because I need to isolate the x variable first. Unlike that other one we solved where we had to do the square root step first because the everything was buried inside of the square function. All right, now here, my next step will be to take a square root on both sides. But what does that give me? So I'm going to say x is equal to square root of 4 is 2, but also what if I just asked you what is square root of 4, you would just say 2, right? You wouldn't say negative 2 because square roots do not give negative answers. So if I just said what is square root of 4, you should just say 2. But if I say solve this equation, x squared equals 4, then what that's allowing for is it's not really asking what is square root of 4, it's asking what number can you square that will yield a negative 4? So does anyone know what is the other number that you can square that will yield a 4? Did I say I meant positive 4? I didn't mean to say negative 4 if I did. So does anyone know what is the other number that you can square that will give 4 besides just 2? Okay, it should be negative 2. Negative 2. Right, because negative 2 squared is 4. So the x-intercepts are 2, 0 and negative 2, 0. So there are two x-intercepts, just like we said there would be. And by the way, the y-intercept, usually the y-intercept is much faster to solve. Just takes a little bit of evaluation. So setting x equal to 0 in the function, or not the function, the equation. So we'll have y is equal to 0 squared minus 4, which is going to be y is equal to negative 4. So the y-intercept is 0, negative 4. Now, if you are in certain situations when the equation is acting nice and the x and y intercepts kind of fall out like this, sometimes this is enough to graph it. Graph the equation. So I could now say, I know I said we weren't going to graph it, but just for extra practice. So if I graphed these 3 points, so if you're in a situation where you do have 2 x-intercepts, well, that's good because now you have 2 points you can graph, right? -2, 0, and 2, 0. Those are my 2 x-intercepts, these two. And then I also have a y-intercept. Then this is almost enough for you to, if you know that this is a parabola, right? If you, and recall the equation as y equals x squared minus 4. If you know that this is a parabola and like the general kind of like U shape it should have, the U shape, and you've got its y-intercept down here, nice and centered between its 2 x-intercepts. Now this is a really nice case, right? You can have much uglier situations where you don't even have x-intercepts, so they're not helpful. But in this case, this is enough to get a decent sketch of the parabola. You might want to figure out what it should be at 1, x equals 1 and x equals -1 to figure out what kind of point it should go through down here, maybe here and here, something like that. But in certain situations, having 2 x-intercepts and a y-intercept, and if you know the shape of the graph in general, then that's sometimes enough to go ahead and plop down a picture. All right. So let's see, finding we did x and y intercepts. Let's look at another one. In fact, I'm going to go back to example 4 and call this part A, and this next one part B, because it's going to be another parabola. And I'm going to say find the x and y intercepts of y equals x squared plus 2. So based off of the facts I wrote earlier, we should expect one y-intercept, always one y-intercept for a parabola, and we should expect 0 x-intercepts because this parabola has been shifted up by 2. But let's see what happens in the math. In the actual mechanics here, what's going to happen? Let's find those x-intercepts first, or at least attempt to. Again, we're expecting to not be able to find any. Let's see what happens. So we set y equal to 0 and solve for x. 0 is equal to x squared plus 2. Okay, that's setting y equal to 0. Now, when I scoot the 2 over, I'm going to have -2 is equal to x squared. Okay, subtracting 2 from both sides. Now, in my next step, I should have square root of -2 is equal to square root of x squared, but that should send off like alarms, right? Because now over here on the right-hand side, that's okay. Square root of x squared is just x, so I'm going to write that there. But here I have square root of -2. Negative values under square roots are not real numbers. And what does that mean? Meaning they do not exist on the coordinate plane, the XY coordinate plane. Because I haven't explicitly stated this, but when you see a graph of x versus y, that's a real number line and a real number line stacked on each other. But this is not a real number. Square root of -2, there is no such real number that does that. That means I can't draw this, these x-intercepts. So the answer here is that the x-intercepts do not exist. So the x-intercepts do not exist. Oops, the x-intercepts do not exist. And what can I say about my picture? So the parabola, that U shape, what does it mean if the x-intercepts do not exist? All it means is nothing wild. It just means the parabola does not cross the x-axis. It seems kind of scary, like what does this mean for my picture? But it literally just means your parabola is shifted up and it doesn't cross the x-axis. That's all it means. So you would have no x-intercepts for this y equals x squared plus 2. Now we can still find a y. It should always have a y-intercept. It's just set x equal to 0, right? So we get y is equal to 0 squared plus 2. So y is 2. So we have a y-intercept at 0, 2. That's fine. Should always have a y-intercept for these parabolas. But there are no x-intercepts. Cool. And if you did want a picture of this just for your notes, this y equals x squared plus 2 graph, and like why it has no x-intercepts, why this is true here with a picture, I'll give you a quick sketch of it here. It is a parabola that has been scooted up by 2, so it's sort of this shape. So you see, does not cross the x-axis, because this is the x-axis, right? The horizontal line. Cool. All right, let's move on to different shapes. Circles. Equations of the form. Now, I'm going to write a form here that's going to be like a specific kind of circle. Later in this lecture, I'm going to give you the actual general definition of a circle. But when I do that, I'm going to write the full list of each type of shape and their general form that we've covered so far. So here I just want to use kind of a safe little example. So equations of the form x squared plus y squared equals 1 are circles. And the point I want to make here, I don't want to scare you with all the generality that we're going to see in a bit. The point I want you to note here is that we were noting the exponents earlier, right? If both of the exponents are 1, then it's a straight line. If the exponent on the x value is a 2, then it's a parabola, right? Now here they're both. It's in a slightly different form. Y is not explicitly solved for like the other forms, and they're both squared. So the exponents on both x and y are 2. They're both squared, right? And there's also something we need to say about the signs of them, but let's not. If you change the signs, you can end up with a different shape called a hyperbola, but let's not worry about that. Let's just look at this. So if you see something where both of the things are squared, then the exponents on both the x and the y are 2. So without getting too into circles yet, let's just practice finding their x and y intercepts, because it's a good example. It's more practice manipulating these equations, a little bit more practice solving the equations. So let's say, I'm going to call this part A, find the x-intercepts and y-intercepts of the circle, or I'll just say the equation, and sketch a graph. Now, knowing that the shape is a circle is going to help, obviously, with graphing it. All right, so let me give you this. Yeah, we'll do that one first. X squared plus y squared is equal to 1. So that's a very specific circle. All right, let's find the x-intercepts first. Maybe there's, how many will there be? Well, let's see. And it'll depend for circles. In this case, we'll have two of each, but it can depend on where the circle is, whether it has 2 x-intercept. Just like a parabola, it depends on where it is, whether how many intercepts of each kind it has. All right, so we're going to set y equal to 0. So we have x squared plus 0 squared is equal to 1, just setting y equal to 0 there. X squared is equal to 1. And then recall from last time when we had x squared equals 4, we had to write x equals 2 and negative 2. So here I'm going to have the square root of x is equal to square root of 1 plus or minus square root of 1. Technically, I should say plus or minus square root of 1, just like with the square root of 4. And then since this can be reduced, square root of 1 is just 1. I can say x is 1 or x is negative 1. Okay, and that's giving me the 2 x-intercepts 1, 0 and negative 1, 0. The y-intercepts, we're setting x equal to 0. And you're going to see something very similar happening here. If x is 0, we have 0 squared plus y squared is equal to 1, which just yields y squared is equal to 1. But that's the exact same equation, it's just the letters different, right, as the first step up here. So that means I'm going to have, I'm just going to kind of skip the steps and say y is equal to 1 or y is equal to negative 1. And that's yielding 2 y-intercepts here, 0, 1, and 0, negative 1. Okay, and remember the x value is 0 because that's the definition of a y-intercept. You set the x value equal to 0, and then you find the y value. So here's y equals 1 corresponds to this y-intercept, y equals negative 1 corresponds to this y-intercept. All right, draw this on a graph. Draw these, we have 4, we have 4, 2 of each here. So if we drew this on a graph, I'm going to kind of say, I'm going to put 1 all the way out here just to really emphasize. So that's 1. Actually, that's 1, 0, right? Up here would be 0, 1. Over here on the left is an x value of negative 1 with a y value of 0. And then down at the bottom, x is 0 and y is negative 1. That's where my 4 intercepts are, 2x and 2y. Let me just really emphasize those. All right. And now I know from the shape of the equation, x squared plus y squared equals 1, and that fact I gave at the before this example, that it should be a circle, right? It should be a circle. So based off of these 4 points, I can kind of do my best to make a circle out of this. Now, what about getting points in between? So with the parabola, I didn't just say, look, it's a parabola, just believe me, right? We actually graphed some points and saw how it was getting more curved, like it's getting steeper, right? We did some tables of values. Not advised here, because circles, it's going to be hard to find nice values. You can find nice values to plug into a parabola, no problem, right? But here, if I wanted to know, like, what is it at 1/2? If x is 1/2 right here, then what's this y value? You're going to start getting into some ugly square root values, and unless you like are good with the algebra and also have a calculator to approximate your answer, that value is not going to tell you much. It's going to be a hard point to find. It's going to be a hard point to graph. Really, the best thing to do with circles is going to be to just know that it's a circle, and then possibly find its xy intercepts, and also maybe find its radius and center. That would be a nice way to define the shape of a circle, which we are going to do. But first, a little bit more practice finding x and y intercepts. So let's say part B. Sorry, I'm thinking. Let me say x minus 2 squared plus y squared. Hang on. Do I want? Don't write that yet. I'm not sure if that's what I want. I want a circle. Four. Okay, sorry, I'm just making sure that's what I wanted. So same instructions as part A, find the x and y intercepts. Find the x and y intercepts. All right, x-intercepts. Setting y equal to 0, I'm going to have, can I skip some steps here? If I know 0 squared is just 0, then I end up with x minus 2 all squared is equal to 4. Next step here, square rooting, right? Since this x minus 2 is packed into this square, I'm going to square root both sides, and that's going to effectively give me x minus 2 is equal to plus or minus square root of 4. There's that plus or minus coming there. Plus or minus square root is introduced because we're solving an equation. And then, of course, that's just x minus 2 is equal to 2, right? Square root of 4 is 2. That's the positive one. Or x minus 2 is equal to negative 2 because square root of 4 is 2 and then with the negative outside. So two separate solutions here. Both of the equations I'm going to add up to solve for x. I'm going to add 2 to both sides, right? So here, this one yields a 4, adding 2 to both sides. Now here, if I add 2 to both sides, what happens? Well, we get 0. Okay, cool. So my two x-intercepts are 0, 0, coming from that one, x value of 0, which is what I just solved for, and the y value is always 0 for an x-intercept. And my other one is 4, 0, 4, 0. All right. Y-intercepts, or maybe there's not 2 this time, let's see. Setting x equal to 0, so I'm going to say 0. Now I need to be careful here. Setting x equal to 0 doesn't mean I can just completely disregard this whole thing, right? The x is 0. So I'm being careful here about actually plugging in 0 for x and not just like disregarding the whole thing. Now here, 0 minus 2 is negative 2, right? That yields negative 2. Negative 2 squared is 4. So I'm getting 4 plus y squared is equal to 4. Trying to solve for y, right? So I'm going to combine like terms. I'll subtract 4 on both sides, which will effectively cancel that both of the 4's out, right? They both go away, and I just have y squared equals 0. So technically at this point, I should say y is equal to plus or minus square root of 0, but the plus or minus doesn't mean anything when it's a 0, right? 0 is gonna, it doesn't matter if you make 0 negative, or it doesn't care. So we only get one solution here, which is y is equal to 0. So my corresponding y-intercept, x value is 0 by definition for a y-intercept, and the y value I just solved for is a0. So remember that I said this last time, if a graph of an equation goes through the origin 0, 0, then you should see that point come up in your list of x-intercepts and your list of y-intercepts. Can I graph this? Can I graph the circle now? Because I know it's a circle. I don't have two y-intercepts this time. So can I graph this using just intercepts, like I did with example A? Well, let's see what happens. Let's just try it out. So I need to go 2, 3, 4. I'll just go out to 4 in each direction. Okay, so the first x-intercept is at 0, 0, and in fact, that's my only y-intercept. And then my next x-intercept is at 4, 0. Okay, so let's see. I'm gonna call on, let's see. Aviana, can you tell me like what you think this circle would look like if I know that based on the y-intercept that it only crosses here? If you had to describe a circle that was originally centered at the origin, like the first one, would you describe this new circle as being shifted right or left or up or down?
I would say it would shift up.
So let's see, if it shifted, imagine this circle here that we drew back here, the original one that had all 4 intercepts. If it shifted up, it would still be crossing the y-axis in 2 spots, right? So what if I took it and shifted it this way to the right? That could possibly get it to where it only crosses the y-axis in 1 spot. And that's what's happening here, but kind of the point is that you can't really tell, right? Like that's kind of the tough thing. So the answer here is, can I graph this using just just intercepts? We can say not really. Now I can, because I kind of know how circles work, and if you would like the picture, it's well, you know, it would be like this, sort of like this, but actually let's not draw it. Let's not draw it because we don't know really how high should I draw it, right? Like, I mean, I know it's a circle, but it would be nice if I knew some coordinate point to like put up here, right? So, or else I might accidentally draw like an egg, like an oval, right? So I'm just going to leave it at that. Not really. We need more. We need more. So here we go. The most general form for a circle is, here it is. So we know it should be like both pieces should be squared. It's going to look like this and then equals the number. We're going to say x minus h squared plus y minus k all squared is equal to r squared. Now this isn't too much more wild than the example I gave here that we just tried to graph, right? I mean, it's a little bit, right? Like nothing is happening to y for real in the example I gave, it's just squared. But if you imagine if I subtracted like a 1 from it, then it would look of this form. It's just these letters are taking the place of the numbers, right? So I got to tell you what these letters are, where h comma k is the center of the circle. And r is the radius. Those are going to be the things that we really need. These are going to be the things that we really need to graph a circle. If I asked you, what are the critical things you need to graph a straight line in its equation form, y equals mx plus b, you would point at m, you would say the slope m, and the y-intercept b, right? For a circle, the analogy is, what's the important thing that you need to graph a circle? Since x and y-intercepts are not always useful, you would say the center and the radius. Based off of this equation and this information, what is the center and radius of my circle up here? Well, my center, which I'll do in green for this circle, so I'm going to put it up here. The center is going to be the value that's subtracted from x, that's the x component. So you see the -2, the 2 is playing the role of h here. The 2 is playing the role of h. So that is 2 for the x value. And then what's playing the role of k in my equation up here? Well, there's nothing, right? So it's a 0. It's technically a 0. Okay, does that make sense so far with what I've drawn here? Yeah, because 2, 0 is right there. Okay, so that's fine. If my center was like all the way out here, I might say, what the heck is going on? But this so far is good. This already kind of makes sense with what I was saying earlier, that the circle should kind of be over here. And what is my radius going to be? My radius, now, what is playing the role of r here? R is the radius, r squared should be 4. So the radius is not 4, right? R squared is 4. So that means my radius is 2. My radius is 2. Why? Because r squared is equal to 4. So that's something students forget a lot. You kind of just want to skip a step and just say, oh yeah, r is 4. But you have to remember to take the square root of it and say if r squared is 4, that means r is 2. Now, why is that helpful? Why is that helpful? Because what I can do is, I need to write some stuff down. Let me write some stuff down here. And then I'll redraw this graph. So once I have the center, which in this case is 2, 0, I can find 4 more points. So I'm abandoning x and y intercepts for these circles because I'm finding that they are not always useful, right? So I've got a better method here. I can find 4 more points by doing what with the radius? By adding the radius to, oh shoot, I should say adding and subtracting, sorry, adding and subtracting the radius 2 from the x and y values of what? Of the center. All right, so let me redraw my graph. You don't have to redraw yours. You can just keep work. I'm doing it just so you can see what I'm doing here all on one page. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. All right, so I already had, well, actually, let's just pretend we are just starting from the center, which is 2, 0. All right, so what the heck do I mean about adding and subtracting the radius from the x and y values of the center? Well, I can say that the center 2, 0, how about I add 2 to the x value? That will, what point will that give me? That will give me the point to the right of the center 4, 0. Okay, so right there, which by the way, we already knew, right? We already knew that point, but we're just starting straight from the center. We're going to find these other 4 points. Now, what if I take my center and I go up? If I go up, that means I'm going to add to the radius 2 to the y value. So I'm keeping the x value fixed and adding 2 to the y value. So this moving to the right twice, I'm adding r equals 2 to x. Adding, so plus r equals 2 to x. That's how I got 4, 0. Now here to go up, I'm adding r equals 2 to y. Adding plus r equals 2 to y. That's why the x stayed at 2 and 0 plus 2 is 2. Where's that point? It's up here. Okay, that looks good. Now, what if I take the center and I go left? That's going to be subtracting r equals 2 from the x value. Subtract 2 here, and I get 0, 0. Which, by the way, is a point we already knew. The point we already knew. Okay, and finally, so I've gone right, up, left, let's go down. So from center, let's go down. That means I'm going to subtract 2 from the y value, keeping the x value fixed. 2, comma, 0 minus 2 is negative 2. So my final point is down here. And look, now we have our circle, or at least we have 4 dots, and we don't have to be artists here, but we can sort of just draw some curves. Oh yeah, that's not the best, but there it is. There's my circle. All right, so let me close with an example where we do all this again, right? Because that was a lot. So let's do it all again with new values. New circle, new values, new radii, and so you can get some practice with that general form, pulling out the center and radius, and also finding 4 other points. So just in case you need, hang on, sorry. All right, there we go. In case you need that still. Yes. I got you. In fact, I'll just take attendance right now before I forget. All right, cool. Okay, so let's say, I think this was example 6. So what am I going to say here? Find the center and radius of the circle sorry, 1 second. Okay, the circle x plus 1 squared, and then plus, so there's that first part, and then y minus 3 squared is equal to 9, and then find, hang on, let me think, have I given, yes, this is fine, find 4 other points besides the center to help you sketch a graph. Oh, can we do this? I'm gonna have to go fast. Okay, so you may not be able to keep up here, but try to keep up as much as you can. And you can always go back and review this video after I put it up in Canvas. Okay, so quickly, the formula is x minus h all, this is the general form, right? X minus h all squared. I'm just rewriting it. You don't need to rewrite it. You've already got it written down. So here, my center is h comma k, right? So clearly the k value should be 3, but what about this plus 1? Well, in the formula, it's already set up to be subtraction, which is a little weird maybe, but that's okay. It's set up to be subtraction. So if this is a plus 1, hopefully it makes sense to you that I should have a minus 1 there. Okay, so h, playing the role of h, is a negative 1. That way it's minus negative 1 to match with this plus 1. And then, so that's my center. Oh, I didn't write it, center. And my radius is going to come from r squared equals 9. So I give you a nice perfect square number there, so is 3. Now, 4 other points. Okay, so I'm starting with my center, negative 1 comma 3. I'm going to go to the right first. That means I'll add 3 to the x component. So I'm going to the right, adding 3 to the x component gives me 2 comma 3. Now I'm going to go up from my center. I'm going up. That means I'm adding 3 to the y component. Now I'm going to take my center and I'm going to go left. That's going to subtract 3, right? Going to the left is subtracting 3, that radius, from my x component, negative 4 comma 3. And then going down 3 corresponds to subtracting 3 from the y component. Okay. if this part is tripping you up, it may help if you draw it and do these as you draw them. That can kind of help bring it all home here. So let me see, I need a fairly big picture here. It's a bigger circle, has radius 3, right? So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right. What do? We graph these points. We graph these points. Now, technically, you don't really, I mean, you can put a dot for your center, but it's not part of the circle. It's more of like a reference point. So I'm going to do it in green just so we know it's like not really a part of the circle, but there it is, -1, 3. Now, the 4 points I actually want to graph are the points that are actually along the circle. So from my center, I went 3 over to get that point 2, 3. I went 3 up to get the point -1, 6. There's that point. Okay, I went left from my center by 3 to go to the point -4, 3, which is there. And then from my center, I went down 3, which put me on the x-axis right there at -1, 0. So you see, I'm just going from center, going 3, 3, 3, 3, and finding these nice points straight up and down and straight to the left and right. There we go. There it is. That we just finished section 1.2. I believe that's all I want to do in 1.2. So next time we'll talk about 1.3, which will be lines, and we will get in. So on Monday, we'll talk about lines and also get into solving quadratic equations. So you should be able to do the homework for 1.2 now. All right, I'm going to stop recording. You guys are good to go.